we're going to look at substituting in an entire. So we got here, here, here. Okay, so here we are. So finding the composite function and its domain. All right. So with the domain, if one function will be the domain for f of x with x equals 2x, right? Good. And what would the domain be for g of x? All real numbers. So if f and g are both all real numbers, the composite is also going to be all real numbers. Okay? All right. So let's see. So here we have f of x equals 2x squared plus 2x minus 5, and g of x is 3x plus 1. And we want to find f of g and then g of f. Okay. Okay, so in the past, we had with f composed with g, right? We would put g of x inside of f of x, right? And then whatever we were substituting in here, that would go first, right? And whatever that output is, we would put into the f of x. But there's no number to put in this time. So we have to put the entire g of x inside each one of the x's for f of x. So the outside function, it's like you're cutting out the x's and you put parentheses. So this will be f of x, f of parentheses equals to parentheses squared plus 2 parentheses minus 5. Okay, and then we're going to put g of x in. So we're going to put g of x is 3x plus 1, 3x plus 1, 3x plus 1. Okay? Well, with this, we can't say 3 squared x squared. We cannot do this. We cannot do 3x plus 1. We cannot do 3 squared x squared plus 1 squared. No good. Well, but we can do this. If it was 3x times 1, right, squared, now we can do 3 squared x squared times 1 squared, right? This we can do, this would be 9x squared. Well, what's the difference between this one and the first one? Yeah, this is all multiplication. This one we have addition, right? When you got a plus sign in between there, you cannot distribute that exponent like you could if everything is multiplied inside parentheses. So what we have to do here is, it's like we're putting in a copier and hitting 2 copies. This will be 3x plus 1 times 3x plus 1. So we square what was inside the parentheses. Just like if 2 as an example, 2 squared is 2 times 2, right? Or x squared is x times x. Well, the same thing holds true for points. Okay, and then here we can go ahead and distribute. So we're not doing anything else here yet. So here we can distribute the 2, and so that'll be 6x plus 2 minus 5. Okay, questions with that? Okay, now we can FOIL, right? So 3x times 3x gives us what? X squared, and then 3x times 1, that's 3x, and 1 times 3x, 6x, right? So let's do that. 3x, right? 1 times 3x, that's 3x, and then 1 times 1 is 1, plus 6x, and then 2 minus 5 is a negative 3. Questions? Okay, so we did a FOIL here, right? Well, we need to combine like terms, right? So there's nothing to combine, nothing else to combine with the x squared. So that'll be 9x squared. What's that? Yeah, and then you got 3x and 3x, 6x, and 6x is what? 12x. And notice I'm doing like a tally. I mark it as I do it because it's really easy. A lot of times students will miss something like this. But if you mark it, then you see, oh, I got this one. Or at least combined with a negative 3, right? And 1 minus 3 is a negative 2. Okay, so we took two functions, right? Put f composed with g and came up with a new function. So the domain, well, it's 9x squared, right? X is not in the denominator, x is not in the radical, so domain is all real numbers, right? Questions there? Okay, so now we're going to do G composed with F. Okay, we good? Can I erase this? Okay, so we did F composed with G. Now we're going to do G composed with F of X. Okay, all right, so let me erase this and erase this. Okay, so what do we do now? Yeah, we've got to take f of x and put it inside the g of x, right? So it's like we're cutting out the x, okay? And you're going to put in here g, parentheses, equals to 3 parentheses plus 1, and then you're going to take this and put in the parentheses, all right? So go ahead and do that, and I'm going to get attendance here real quick, okay? Go ahead and do that. Okay, everybody check that. And so as you do it, I'll go ahead and do mine. And that way you can check and see how you're doing. Okay, so this is what you should have ended up with. So we said that we're taking the g of x, like we're cutting the x out, put parentheses, and we put the f of x in there. So that'll be x squared plus 2x minus 5, and distribute that 3. And we end up with 3x squared plus 6x minus 14. And again, our domain is, yeah, all real numbers. Okay? Questions with that? Alrighty. Okay, so they did the other way around, but that's okay. All right. So let's see. Okay, so now to show, now in this chapter they call it when two composite functions are equal. But in reality, they are equal. But this is what I was telling you about when everything cancels out. In other words, if they're inverses of each other, then everything will cancel out and all you get is x. So let's see now, which one is this? 2x minus 5, okay. Okay, here we go. So f of x is equal to 2x minus 5, and g of x is equal to 1/2 x plus 5. And we want to show that f composed with g equals to x, and g composed with f equals to x. Now, if these two functions are inverses of each other, then you're going to get x. Well, if one equals x and the other one equals x, then you can say that these two functions are equal, right? Or they're equivalent. Okay, so let's start with f composed with g. Okay, so that'll be f composed with g of x. All right, so which one are we going to cut the x out of, and which one are we going to put inside? Yeah, you can take the f of x, cut the x out, you can put the g of x function inside of that, right? So that'll be f parentheses, right? 2 parentheses minus 5. Okay? And now we put the 1/2 x plus 5 in there. 1/2 parentheses x plus 5. Okay? All right. So the thing is, this is 2 over 1, right? So if we just did away with the parentheses, right, we've got 2 over 1 times 1/2 times x plus 5 minus 5, right? So can we cancel anything here? Yeah, the 2's, right? 2's cancel out. They go to 1. 1. So we get, so now this is just 1 times x plus 5, so we can do away with the parentheses. Plus 5 minus 5. Well, x plus 5 minus 5 is x. Okay? So technically, if you can do it one way for the problems that we're doing, you do it the other way and you get it. So you can really only, you can get away with doing it with just this way. Well, let's go ahead and try G composed with F just to see how that works, because it is a little different. Okay, we good? Can I erase this? All right. Now we're going to do G composed with F, and we should get the same result. Okay? So, go ahead and do this one. Go ahead and do this. Okay, so you're going to do G, parentheses, right, equal to. And I'm going to let you kind of work it from there, see how you do with that. All right? Go ahead and try that. I'll give you a couple of minutes for that, and then we'll see how we're doing. And I'll go around the room and just let me know if you have any questions. All right. That's pretty stupid, that Okay. So this will be 1/2. And then I'll put a bracket because too many parentheses just kind of. So we're going to take this x, right? And we're going to cut that x out, put parentheses, okay? So that might help a little bit. So you can put parentheses plus 5, close it. Okay? All right. What's going in the parentheses? Yeah, 2x minus 5. 2x minus 5. 2x minus 5. Okay. So we've got to simplify inside the parentheses, right, before we can multiply. So we can just do away with these parentheses, right? And what can we simplify here? Yeah, -5, +5, they go to 0, right? So now all we're left with is just 2x inside the parentheses. Well, what happens to the 2's? Yeah, they go to 1, right? Cancel out, they go to 1. And so all we're left with is x. So it's confirmed that f of x and g of x are inverse functions of each other. But right now, their book is just calling them equivalent. Okay? Questions with that? Yes?
So, give you an example of freshman.
Do you what?
The freshman, you use freshman.
You mean right here? So, yeah, you're not you're going to substitute the 2x minus 5 inside of x, right? So you don't do any, you have to simplify inside the parentheses first, right? So the 5, so really, since there's nothing to do with the parentheses, you can just drop parentheses, and then the 5s cancel each other out, right? They go to 0. And so the only thing you have left inside the parentheses is 2x, right? So, I mean, in the past, you would probably want to distribute that 1/2, but that's if you can't simplify inside the parentheses, right? Here, we can simplify inside the parentheses, so you want to do that first, okay? Normally, you don't have to simplify. Normally, in something like this, you don't have to simplify inside the parentheses, but here, because we substituted in an equation, right, 2x minus 5, and now that changes it a little bit, right? Now you got to simplify inside the parentheses, whereas before you didn't have to, okay? All right, good questions. Anything else? All right, so you see how that works. They did it a little bit different. They put the 2 underneath. Yeah, you know, it's the same. The algebraic process is the same. Okay. All right. So let's look at these problems here. Find the domain. Oh, wait a minute. Hold on. I don't think we're doing that. Find the domain. F composed with G. So with F composed with G, we've got F equals 2x plus 8, and G of x equals 5 over x plus 2. All right, and I'll write 9 down also. 4x plus 10 over x. Okay, so with this, we want to find the domain. Well, here we've got x in the denominator, right? So we're not going to get all real numbers. So we want to find the domain of f composed with g. Well, first we have to find what that is, right? So that'll be f composed with g of x. So we're going to cut out that x, right? And so this will be f and then parentheses, right? And then x parentheses plus 8. And then we're going to substitute in 5 over x plus 2 in there. 5 over x plus 2, right? So we're going to get 5 over x plus 2 plus 8. Okay, so from here, basically, we just take the denominator. Okay, x plus 2 equals 0, and x cannot be a negative 2. So our domain, all values in set x such that x cannot be a negative 2. Okay? So we just put the functions together as a composite. You just follow the rules of finding a domain. Yes?
So you did only the bottom at the top.
Yeah, no, because when you have x in the denominator, right? Because if you graph this, because if you have x in the denominator, then you set the denominator equals 0 and solve, right? If you graph it, right, transformations, this is going to move to the left 2 and up 8, right? So negative 2 and up 8, right? So your curve, your domain is still all real numbers except negative 2, okay? Because that's where your vertical asymptote shifted to, right? So, but that's all you had to do, okay? All right. Okay, I kind of erased this other one here. I'll just rewrite it. Okay, so that's that one. And the other one, I said was f of x equals to 4x plus 20, and g of x equals to the square root of x. Okay, so again, we're looking for the domain for f composed with g, right? So this is kind of running out. This will be f composed with g of x again, right? So go ahead and do this composite function. All right. You're going to cut out the x again, right? So go ahead and try that. No, don't need that big.
What did your GX say?
Sorry, I kind of squeezed that in there. Let me rewrite that. Okay, that's better. Okay, so you should have just put square root of x in, right? So we get 4 square root x plus 20. Okay, now if we don't have all real numbers, right? Because x is in the denominator, in the radical. So now, how do we find the domain if x is in the radical? We take the radicand, and what do we do with it? Set it equal to greater than or equal to 0. Okay? We take the radicand, set it to greater than or equal to 0. If the x is in the denominator, we set it equal to 0. But if x is in the radicand, then we set whatever's inside, not just x, but whatever's inside to greater than or equal to 0. Here it's just x, right? So if we had the square root of 2x plus 3, then we would put 2x plus 3 is greater than or equal to 0 to find this domain, okay? But, so you put the whole radicand. Well, since x is the only thing that's in there, then we're done. So our domain is all values in set x such that x is greater than or equal to 0, and that's it, we're done. Well, why is that? The 4 4 times. So instead of 1, 1, right? Now it's at 1, 4. And then the plus 20, what's that going to make it do? Shift up to 20, right? So here it's 20, but now instead of being at 1 and 21, now it's at 1 and 24. So it's stretched it. But the domain, is still 0 to infinity, right? X is greater than or equal to 0. Okay? Questions with that? Alrighty. Let's try another one. You guys do this one. For the given function f and g, find the requested composite function and find its, I'm going to add to it, find its domain. All right, go ahead and do that one. Okay, so we cut the x out, right? And we go ahead and put it in our equation. All right, go ahead and continue with that, simplify that. And I'd like to have somebody come up to the board. All right, anybody want to come up to the board? Really, there's only one thing left to do here, right? You want, okay, come on up. Yeah. Maybe you just copy what I got here.
Maybe you should help at the end.
Okay, no problem. Make it right big so that everybody can see. Turn the light up so I can see better. No, that marker's drying out. I gotta use this one. Throw that one out. Yeah, that's better.
Man, I just substituted it, right?
You just simplifying, right? So what can you combine inside the rect?
Oh, it makes sense.
Yeah, there you go. Okay, that's it right there. Okay, so that's your composite function, right? Now we want to find our domain. So
Right, and you can be the gradient equal to.
yeah, so you take the Radican, right? Set it to greater than or equal to 0 and solve.
So you be like,
So you take 8x minus 4. There you go. That's right. And then you just solve for x from there. Right. Right. X is greater than or equal to. What is that? 4 over 8 simplifies to 1/2. Right. So your domain is 1/2. And that's it. That's your domain. So now you would write that, right, as all values in set x such that x is greater than or equal to 1/2. And put in curly brackets and you're done. Okay? Questions with that? Yes.
so even though this equation is really outside,
No, 3 is not outside. 3 still, because see, 3 is inside. Okay, the question was asked. See, this 3 is inside, right? So it's inside here. So it's not like this. You got to be careful when you write it. That's different than this, right? This, the 3 is outside. Here, the 3 is inside. If the 3 is inside in the original function, then 3 has to be inside in the composite as well, okay? So that's why these two can simplify. We can combine those, combine like terms. Okay? And so we end up with the square root of 8x minus 4, and then take 8x minus 4 greater than or equal to 0, and we get x is greater than or equal to 1/2, and so that's our domain. Okay? Questions there?